A charge q is placed at the center of an uncharged hollow metallic sphere of radius a. Find the surface charge density on the inner and outer surfaces. Fine. Now let's say I do have a sphere whose radius is a. A charge capital Q is placed at its center. Now the concept of solving this question is that the net electric field or the net electric field, we must say electric field only. So the electric field inside the metallic conductor should always be 0, and that will be 0 if the net charge inside is 0. Fine. Now since we are talking about inside of it, so equal and opposite charge, that is negative of minus q, will be induced on the inner surface of the sphere, so that the electric field originates from here, ends at here, and so that the electric field passing through the metallic conductor is 0 and the net charge enclosed is also 0. So the minus q charge is induced on the inner surface. Now clearly that since this outer surface, I mean the total metallic sphere, does not have any net charge, and if minus q is inducing on the inner part of it, so equal and opposite, that is positive q, will be induced on the outer surface of the metallic sphere. Fine. So the surface charge density in the first case for the inner surface will be given by total charge on the inner surface, that is minus q, divided by area, that is 4 pi a square, and similarly surface charge density for outer will be plus q by 4 pi a square. If a charge q is put on the sphere, what would be the surface charge density on the inner and outer surfaces now? Let's say if I put a charge q on the outer surface now, then clearly that inner surface will not be changed. I mean the charge on the inner surface will remain the same, because what we want is that the net charge inside a sphere has to be 0. So net charge on the inner surface won't be changing, it will be remaining the same, that is minus q, and so the density. But for the outer case, the net charge on the outer surface is now q plus small q. So it will be q plus small q plus divided by 4 pi a square. Fine. Now in C part I have to calculate the electric field where at a distance x. Now let's say when x is less than a, so electric field will be given by, I'll use the Gauss law, that is E dot 4 pi x square is equals to q by epsilon naught, because at this instant, that is when the surface is taken at a distance x. So net charge enclosed is capital Q, so electric field comes out as q by 4 pi epsilon naught x square. Fine. But when x is greater than a, then the net charge enclosed is 0. So when x is greater than a, then still the electric field will be given by q by 4 pi epsilon naught x square. That will remain the same. Fine.